Hello, everyone, and welcome to our meeting about virtual threads in Java. So what exactly is a virtual thread? Well, in order to understand what a thread is, a virtual thread is, we first need to understand what a thread in general is and understand the difference between working with threads, multiple threads, and working with multiple processes. So in order to understand the difference, just imagine your desktop, your computer, and imagine that you have multiple applications running on your computer. Each and every application is a separate process. Each process has its own memory, and the operation system just split the power of the CPU or the multiple CPU between those processes. So it happens so fast that we feel that those processes run concurrently with each other. Actually, it's not accurate because if we have only one CPU, it can never be exactly in parallel computing, because it is about splitting the power of the single CPU between those two processes or more processes. So it's kind of an illusion that we have concurrent programming. It's not exactly, it's not necessary. So we understand what multiple processes is all about. Now let's talk about threads, not virtual threads, just threads. You can imagine that each process is composed of multiple threads. Each thread, you can imagine it as a small creature, small person that goes over the code and execute it concurrently with other threads. And those threads in a specific process can share the same memory. So there are lots of problems we need to handle when creating a program with multiple threads. Now, let's talk about what happens behind the scene. When we have simple threads in our program, each thread is mapped with a native thread the operation system handles. So the way the operation system divides the CPU power between the threads is actually achieved using the native threads the operation system handles. This is also the reason why usually you will hear the recommendation to create threads in the beginning of the program. Creating a thread consumes lots of computing power because it is about creating a new object that is mapped with a native thread the operation system handles. So it is not only about creating a new object, it is also about creating the native thread. Okay, so this is what happens when we work with threads. What a virtual thread is. Well, the definition you can find is not exactly accurate, and I will explain. But the definition you will find about virtual thread is that it is a thread, but without a native thread running on the operation system level. Well, it's not accurate. You will see in a moment. But you can certainly say that when creating new virtual threads, we don't create native threads in the operation system level, unlike when creating simple threads. When creating simple threads, not virtual threads, just threads, every new thread you create involves with the creation of a native thread on the operation system level. When creating a virtual thread, it doesn't happen. Okay, let's take a look at the code sample for creating a new virtual thread. But first, I just want to mention, when working with the JDK, there are various capabilities that are not exposed by default. You need to expose them. So when you're executing the code, you need to configure through the IDE that you want to enable a preview of those capabilities that are not exposed. So specifically for our topic, if you want to use virtual thread, you need to add this argument to the compiler. You can easily find instructions how to do it on the web. So after you configure the execution of your project, then you can execute it. Now let's take a look at the code over here. What do we have? So over here, we refer a method that its name is of_virtual. It is a static method that was defined in class thread. And when you invoke that method, it returns a reference for an object on which you can invoke other methods, such as name, for instance. As you can see, both the method name and of_virtual return a value of this type. And when you invoke the method name, you specify the name you want to give to that new virtual thread. Then, just as with a simple thread, not a virtual one, you can invoke the method start and pass over the functionality that you want to take place. So if you call start, you can either define a new class that implements Runnable and then instantiate that class and pass over the reference for that object, or you can use the anonymous inner class syntax, or if you are familiar with Lambda expressions, just code the Lambda expression. So over here, we actually create a new thread, and that new thread is not a normal thread, it is a virtual thread, and it will be responsible for doing this specific loop, and will print out to the screen some text. And similarly, we do the same with another thread. Now, when we execute this program, we can see that we have two threads, but these are not the threads we usually work with. These threads, we would treat them as virtual threads. Now, underneath, if you want to understand what exactly happens here, we do have native threads on the operation system level that enable this program to execute the way it executes. But those native threads are not mapped specifically for the new virtual threads we create. Well, they are mapped to these virtual threads, but we don't have a Catholic marriage between the two, as we have when using threads, not virtual ones, just threads. So what exactly happens underneath, behind the scene? Well, I will jump forward and then backward. Underneath, there is a pool of threads. The JVM maintains a pool of threads. Usually, the number of those threads is the same as the number of the cores we have on that specific machine the JVM is executed on. And whenever a virtual thread is created, the JVM simply schedules its execution on one of those platform threads we have. So actually, those virtual threads we're talking about are actually threads eventually. But if we develop a program that creates multiple virtual threads throughout its execution, unlike just the plain thread, when you're using virtual thread, we won't end up with the creation of a huge number of native threads. We still have a pool of platform threads. Each one of them is mapped to a native thread. So those native threads, that pool of threads that each one of them has a native thread mapped with, those are the threads that enable the virtual threads to execute. So if we go back to the first definition, when creating a virtual thread, and that virtual thread is executed, there is a native thread running on the operation system, specifically for that virtual thread. But that native thread doesn't belong to the virtual thread. It will be used for running that virtual thread, and it will be used for running other virtual threads that will be created during the lifetime of the program. So we can finalize and say, when creating a virtual thread, we don't create a native thread underneath. There is already a pool of threads, platform threads. Each one of them is mapped with a native thread. And those native threads that already exist and are managed as a pool will enable the execution of every virtual thread that will be created during the execution of our entire program. So the definition is not as it is understood the first time you read it. It is a bit different. There is a native thread underneath, but there isn't marriage, kind of a Catholic marriage between that native thread and a virtual thread. That native thread will be used again and again for running every new virtual thread that will be created during the lifetime of the program. But you can certainly say that when you create a new virtual thread, you don't create underneath a new native thread, as it happens with creating threads, not virtual ones. So it depends what your program is doing. If your program needs to create multiple threads again and again, you can make things simple by using virtual threads. Because when doing so, you will have a pool of native threads that will be reused for running every new virtual thread. If you don't use virtual threads, you can still achieve a similar result if you use a pool of threads. So it is up to you to choose which option to go with. Now, a bit more about what happens underneath. Every thread has the stack memory. Now, the stack memory, when dealing with virtual thread, is saved in the heap and is copied to the stack memory of the platform thread that executes the virtual thread when needed. Now, I want to talk a bit about coroutines. I know it's not the topic of our meeting, but I think you want to know about that library. It's not, it's a library in Kotlin, and it allows you to create coroutines. Coroutine is a word that includes two words, cooperative, routine, function. And when creating coroutines, we actually create functions that execute concurrently in the same thread or in different threads. And we can coordinate between those coroutines we create. Now, the shifting of the computing power between those functions, which is performed very fast, is achieved through code running on the virtual machine, not using a native thread underneath. So if you need a huge number of threads, instead of using threads, you might want to use coroutines, because coroutine, the bottom line, is a lightweight thread. But in order to use coroutines, you need to learn Kotlin. So this is another story I'm not going to refer to. I just want to know that it is possible to create lightweight threads by creating coroutines. Because maybe you've thought about achieving the same using virtual threads. Maybe. And if you did, it won't happen, because virtual thread eventually has a native thread underneath that execute that virtual thread. Okay, what else you might want to know? You can also create virtual threads by getting an executor service. The class executors, if you check it, look like this Java. Executor as methods you can invoke for getting an object that works as a pool of threads, and you can use that pool for creating new threads, but it won't be about creating new threads, it will be about using threads the pool holds. So you might want to know about this method that might, okay, see that doesn't show, they don't show it over here. Still not yet, because it's not a standard feature, but when calling this method, you actually get an object that you can say about it is also an executor service, just as getting an executor service object when creating a new fixed thread pool. And when having an executor service, you can just call the method submit and pass over a reference for an earnable object or use lambda expression. And by doing so, instead of having the code executed in a new thread, it will be executed in a new virtual thread. So this is also something you might be interested to know. Okay, this is something we already explained. Now, there is the so-called the carrier thread. The carrier thread is a thread, not a virtual thread, a thread that executes the virtual thread. Now, that carrier thread, it is one of those platform threads that are maintained as a pool of platform thread that allow us to execute virtual threads. That carrier thread might be blocked for some reason. When there is a need for waiting for an input, for instance. So in that case, the carrier thread is blocked, and the virtual thread is copied back to the heap. The stack of the virtual thread is copied back to the heap when that happens, unless that virtual thread is pinned to that, connected to that carrier thread. And that happens in cases where we execute a native method or a synchronized block or synchronized method. It is the same. So these are the cases when the virtual thread is pinned to the carrier thread. Okay, that's it. So it took us 20 minutes, and I'm for you for any question you might have. Let's see. Yes, you asked if in JDK 21 it is still experimental or not. I don't know. Will this session be sent to participants? Of course. Can the slide be shared? Of course. I also want to take the opportunity we have now and invite you to join this online conference I organized by the end of the year, I will arrange you coupons that allow you to join for free. In order to get these coupons, if you are interested, I just ask you to join the event I created for that conference. You can find it over here on the bottom. Extreme J will take place in November. Just join this meetup, and through the Meetup platform, I will share with you the coupon for getting free access. The call for papers is actually open, so if you are interested in taking part, and the same applies to Extreme.js and Extreme Python. Why don't we say Extreme Python? If those domains, if you are interested in those domains as well, then just join the meetups for Extreme Python and Extreme.js as well. Through those meetups, I will share with you the coupons for getting free access. What is the cost, disadvantage of virtual thread? Good question. What do we pay for? What disadvantage? Actually, I find it difficult to answer. Well, if you become familiar with coroutines in Kotlin, I doubt if you look back to using thread, you will move forward and use coroutines instead, for many reasons. But if you're still using threads, using a virtual thread, still it's not a plain simple thread. So I assume there are things that won't be feasible for us when using a virtual thread, but this is something I need to explore to answer. So I can't give you a direct answer now. Okay, then, so it was shorter than expected. Sometimes it happens. I want to thank you for joining the meetup, and I will, of course, share with you the slides and the video afterwards. What is a typical scenario where I will need virtual thread? Typical scenario for using virtual thread. A typical scenario is when you have a program that needs new threads throughout its execution for various reasons, and maybe having a pool of threads for using that pool is not comfortable due to the structure of that program. Maybe it's a program that has multiple parts that are separated from each other, and then it is either you create more than one pool of threads, which makes things a bit more complex, or go with the virtual thread option. This is a typical scenario I can think about when using virtual threads, at least for now. As you could see, it is experimental feature. It's not actually available straightforward. You need to do something in order to use it. I believe they might develop it, and you just need to wait and see where it goes. Okay, then. So thank you very much, and goodbye.